A negation of a statement changes the truth value of the given statement. The symbol for negation is this little wavy line looking like that. For conjunction statements, the symbol that looks like it's pointing upward or the word and mean conjunction. For these kind of statements, they are only true if both simple statements are true. So you have to have two T's for it to be true. We'll go into that a little bit more detail in a second. For disjunction statements, the symbol looks like a V, or the word or means disjunction. For these kinds of statements, they are only false if both simple statements are false. So if you have two F's, then it is false. For all other statements, it is true. When working with truth tables, you have a binary choice. The statements are either true or false, T or F. You have only two options. Now, how do all these things work? It's easier to see it in action. So let's look at a couple of examples. We're going to fill out each truth table, and we're going to look at this first one where we have not P and Q. So I've already filled out P and Q, so easy way to do it if it's not filled out for you is, especially if you only have two, is just T, T, F, F for P, and then Q is T, F, T, F, just alternating. So two T's, two F's, T, F, T, F. Now the first thing we have is not P. So that means not true. If it's not true, then it is false. Not true again, false. Not false makes it true, and then not false makes it true. Simple enough for negation. Now we have the statement not P and Q, which means we're going to have false and true. And like I said up here, for conjunction, they are only true if both simple statements are true. So since this is false and true, they're not both true. This is automatically false. Then we have false and false. So F and F makes it false. We have true and true, which makes it true because both simple statements are true. And then we have true and false, which makes it false. So the filled out truth table for not P and Q would look like this. Now let's do another one. We have P or not Q. Again, P's and Q's have been filled out. TTFF, TFTF. So we're going to find not Q, the negation of Q. So not true is false. Not false is true. Not true is false. Not false is true. Again, negation, fairly easy. Now we're going to go with the statement P or not Q. And for disjunction statements or statements, only false. It's only false if both simple statements are false. So if we have FF, it is false. Everything else is true. So we have true or false, which makes it true. We have true or true, which obviously makes it true. We have false or false, so both simple statements are false, which means that the statement itself is false. And then we have false or true. As long as we have one true, the whole thing is true. So for and statements, they have to be both true for it to be true, and it's false otherwise. For or statements, it's true for everything as long as it has at least one T. If there's one T, then it's true. If it's two T's, it's true. But if they're both F's, then it's false. Now let's look at one that has all three involved. So we have P and Q in parentheses, or not P. So if you're not given a table to set up for yourself, what you should do is set up every individual piece. Like you have P and Q, so that's obvious. I have a not P in there, so I put a not P in here. These are in parentheses, so this gets their own column. And then I just take the entire thing at the end and fill it out here. You can see the same thing that I did here, PQ for both of them. Then I had a not P here, and then the statement itself at the end. And again, not Q here, and then the entire statement at the end. So these can get kind of long, but we're just doing simple ones as examples. So let's fill out the not P column here. So not true is false, not true is false, not false is true, not false is true. And now we're going to do the and statement, P and Q. So true and true is true, true and false is false, false and true is false, and false is false. Now we're going to do the entire thing. We're going to do this column or this column. So P and Q or not P. So true or false is true because it has one true statement for an or. False or false is false because there's no true. False or true, true because there's a T. And then false or true, again, true because there is at least one T. So that is how these truth tables work when dealing with negation, conjunction, and disjunction. Just be careful what each symbol means and how you can find the truth or false values for each one.